For me, it started very small. So I think it was back in high school, I made a small website that presented some information about Ann Arbor, the city I was living in at the time. It ended up being useful to folks. And so that sort of took off, and that was my chance to learn web programming, which is something I really wanted to do. It's a website called ArborWiki. It's an editable website about the city. Anybody can edit any page and create a page just like Wikipedia, but has much more local content. And so now in the decade or more that ArborWiki has been around, there's maybe 10 or 15,000 pages on the site now, and I think the most popular page is probably on birthday deals, so like where can you get a great deal on your birthday? And then the second most popular page is probably either about like city council or like a donut controversy that's going on. You know, it's not world changing, but for people who live there, it's really important. And I think in other locations, it has become world changing. So when there were the campus riots in Berkeley a couple years ago, the local wiki for Berkeley became the place to go for information. For Ferguson, more recently, people have been created this website. They're able to create this website about the city that anybody could edit within minutes, and then start pouring all this information in there from different sources so they could keep track of things as they changed. I ended up applying for the Code for America Fellowship, and I got in 2012, and I was assigned to the city of Detroit with a team of 2 other great folks, my colleagues Prashant Singh and Alicia Rowe. And I think that's one of the most exciting things about local data right now is we're a really interdisciplinary team. So Alicia is an urban planner. Prashant is a computer scientist. He's an engineer. He's a signals processing engineer, actually. So he has the intense data and math side down. And I'm sort of in the middle, sort of bridging these 2 worlds between hard data science and connecting to the community. Through Code for America, we were assigned to the mayor's office in the city of Detroit, and we had a fantastic city partner there, Carla Henderson. And through Code for America, you live in the city for at least a month in February. So your job is to be there and to talk to as many people as possible, to understand what's happening on the ground, to make those connections that'll help a project grow, and figure out what people's problems actually are. So we were working there with Carla. She was in charge of the planning department and the buildings and safety department. And our broader mandate was to fight blight and vacancy, which is a huge problem in Detroit and across the Midwest, and actually in many cities across the US, especially after the downturn. You know, there's a lot of ways you can tackle these problems, and oftentimes the most direct solution is not the most obvious solution. So what we actually ended up finding is that transit was a huge problem and public safety was a huge problem in Detroit caused by these blight issues. So one of the major issues we identified was the lack of reliable transit information, and that's one of the first projects we tackled. And that's sort of tangential to what came out of local data, but it's in many ways it's highly related to the same issues. I think it really starts with the problem and not with the data that's available. And I think that's one of the biggest things we take away is that you have to look at what are people's needs and what are the outcomes they want to see, and then start looking to see what's the data you can find to fit that. What's the data that you need to create to make that happen? So that's what happened in Detroit is we talked to a lot of people who said, if only we had real-time transit information, or if only we had information on where all the vacant and abandoned properties are in the city, then we could start making some change, because we need this information to get started. And so I think having that base understanding of people, and then those people you can go back to present things to see whether they work, to see whether they're effective, I think that's the most valuable way to approach the problem. People assume that cities have a lot of data, and they do, but oftentimes they really don't have the data that they need. They have something that they've collected a couple years ago, or they have something that kind of touches on the problem, but what they're really missing is the core of the information. And it's actually really surprising a lot of times. So you would expect that a city would know where all the businesses are. You would expect that a city would know where all the abandoned buildings are, but they almost never do. It's a very rare case when they do. So sort of our job with local data is to give them the tools to go out and collect that information in a standardized way so that they can share it out and so that they can use it internally for these management processes and to make things better in the neighborhoods. As a city official or someone who's going to be using data, it's really important to understand where the data comes from and who's collecting it. And we have a really great example from a project that came together really fast in Detroit just this winter. So a group of people interested in historic preservation in Detroit were concerned about the amount of demolition, and they really wanted to come to the table and be a part of the discussion about which houses were going to get knocked down. So what they did is they, within a matter of a couple of days, put together this survey of all the historic districts in the city, looking at the condition of every house, whether it fit in with the patterns in the neighborhood, whether it was worth saving or not. And they needed a massive volunteer effort to get this information. So they figured out what questions they wanted to ask. But then the problem is, how do you go out and reliably get this information? So what they did is they didn't just put out a call on Channel 7 WXYZ Action News. What they did is they talked to the people they knew in the field, other architects, other preservationists, people in the planning fields, people who they knew had some background in the area, and then they trained them. So you come in for an hour or a couple hours of training and figure out what it is that you need to collect before hitting the street and collecting it. And then you have review mechanisms on the back end to make sure that the information that's coming in is good. I think all data is going to have some variability in it. It's going to have error in it. And it's a matter of understanding what that error is and whether that's appropriate for what you're trying to do. We did a very successful project with the City of Detroit and Wayne State University that kicked off local data, but we quickly realized that it's useful in a lot of places. So nearly no cities have really great information, especially geospatial information that they can use. And so we built a platform where people can go in the field and collect geospatial information on every house or every parcel or every fire hydrant in the city, whatever they need, asking the questions that they need to ask. This is something that's useful in a lot of locations. So with some support from the Knight Foundation, we spread across the country and did several international projects, and we've been growing since then. Local data has a couple of pieces. So we have a web dashboard where you can set up the surveys and questions you want to ask. And so we've tried to make this really as easy as possible, because our job is to democratize access to this data. So to get it into hands of people who otherwise wouldn't be able to use it because the tools are too complicated, or the tools are so complicated that it's not something that's part of their daily job, right? A lot of these professionals, their job is to make change in cities, to make cities better, but their job is not to understand complex geodata, their job is not to understand web programming, and that's sort of where we come in. So we have this dashboard where they can ask the questions that they want to ask. We use the data that they want to bring, and we help them get that if they need that. So things like a parcel layer, which is the building ownerships or the land ownerships across the city. It's like a buildings layer, so where are all the buildings, or whatever data that they need to collect against, and help them understand what questions they need to ask. So a lot of times groups have a theme that they want to ask, but they often spend tons of time figuring out what the exact questions are that they need to ask, and then they end up with a list of like 30 or 40 questions that they want to take out in the field. And that's really not fair to the surveyors, and it's data that's never going to get used. I think part of the problem is people have been doing surveys forever. It's always been the case. People have been out there with a pen and paper doing this, and this makes doing it digital makes the process much more efficient. It also makes it much easier and faster and simpler for people, because we can help them get that list of 40 questions down to just a couple that really get at the heart of their issue. So they go out in the field using a mobile web app. It's something that they just load right in their browser. Nothing to install, which makes it really easy for things like volunteer survey days. So if you have a group of people who are not technologists, you just tell them to enter this URL in their web browser. They go to the URL, the page loads, and it has all the features you'd expect from a full app. So it can go offline, handles complex data, it takes photos, all these wonderful things that you'd expect from a normal app. Right on the browser, nothing to install. Through the web dashboard, they can see the results coming in live. So they can watch the geospatial data come in, they can watch the map getting populated. They can see how much has been covered. They can identify coverage gaps and say, oh, Matt, you missed a block. You got to go drive back and catch a couple houses here because you missed some, which is just something you simply can't do on paper. And then they have access to all their data, which is a big difference from the process in the past, because oftentimes you'd hire an expensive consultant to do this work. That consultant would go out in the field. They would take maybe their paid surveyors to do it. They would do paper. They would get this stack of paper. So if you're lucky, you end up with a paper. If you're unlucky, what you end up with is a printed report. So a piece of paper that's static data, it's never going to change. It's just sitting there. It's dead from the moment it was created, basically. So what we let them do is keep on collecting data. So as long as they want to keep it refreshed, it's there for them, and they can export it whenever they want. So they have access to the raw data in formats that are useful to them. And I think that's a huge lesson from the open data community, is that we need raw data. We need data in its original format, not with any analysis on top of it, just with the plain data so that people can use it in whatever way that they need to, because you can't really anticipate what all the uses of the data will be. Right now we're dealing with data at the scale of the city. Everybody likes to talk about big data, and especially big data in cities, and the truth of it is that there's nearly no big data about cities. So it really shouldn't be something to get intimidated about, the size of the data or what is it going to take to use it. Most of the data sets that cities have out there are things that you can approach today with something like Excel or Google Refine or Mapbox or QGIS. all these sort of tools are ready to go. And I think there's a lot of fear about what is all the data out there, how do I actually use it. The tools end up being remarkably simple and straightforward and point and click for the large part. Where the really fun mess comes in is the process of getting that data. You're going to have to extract that data from some system, whether that's from a city system or from somebody else's system. You're going to need to transform that data into a format that you can use. So let's say maybe it's in a shapefile, a geospatial format, but you really need to use it in Excel. You're going to need to transform it into a CSV or an Excel file. And then you're going to need to load it into the tools that you have. So what are the tools that what are the tools that you're going to be using, and how can the data be brought into them easily? But before any of that happens, really the most important thing is to find the problem. So what is something that people really need and something that people would really use? And paper prototyping is a great way to do that. If you have somebody who identifies a problem, can you fake a data set that helps them solve that? Can you just sketch it out on a piece of paper, or ask them to sketch it out and say, okay, so what exactly would you want on this? Or what specific variables would you want on this? And sometimes it's just as easy as opening up a blank Excel file and saying, okay, so what do you imagine here? Use paper before you go down a path that doesn't make sense, or before you go down a dead end. One of the first tasks that you're faced with when you have a data set is taking a big picture look at it, and then cleaning it up into something you can use. And Google Refine, or now Open Refine, is one of the most useful projects for that. You can just upload a data set and then quickly look at the different facets of it, see whether there's common misspellings, quickly fix those. And what's nice, and I think a common framework for all these tools, is you want to have a trail of your work. You want to document what you've done to get to where you are. That's going to be useful for you when you need to repeat this process in 2 days, and it's going to be useful to someone else when they want to repeat this process in 6 months. There's all sorts of point-and-click tools out there that are really easy to use, where you don't need to know coding to use them. So using Mapbox to design maps, for example, QGIS to understand geospatial data, OpenRefine for processing information. All three of those are tools that you can download for free, pick up, and use right away. And then, never discount the power of Excel. I think Excel is still one of the most underrated tools. Everybody's looking for flashy graphics and beautiful charts and crazy interactive maps. But the truth of it is, the people who are going to be using your data probably already know how to use Excel, and probably want data in a format that they can futz with as well. And they want data in a format that they can reuse and change themselves. And just having something in Excel with some charts that automatically update might be the most powerful thing that you can deliver.